So chapter 11, which we're going to start today, is about counting and probability. So one of the key aspects and to be able to calculate a probability is that you're able to count the number of ways things can happen. So the first half of chapter 11, we're going to be focusing mostly on these different ways to count things. And then in the second half, we'll start looking at applying those counting methods to calculating some probabilities. But today, we're going to focus on two specific types of counting. The first is called the fundamental counting principle. And what the fundamental principle says if you have three, I guess, or more events that can occur m ways, n ways, and p ways, respectively, then the number of ways all three events can occur is m times n times p. So kind of the standard example for this sort of thing is a getting dressed example. So suppose you have, 4 pairs of pants. You have 6 different shirts. Oops. And 3 different pairs of shoes. And you want to know how many outfits can you make from this? Well, we have 3 different choices that we can make along the way. So for example, we have 4 different pants choices. And then for each of these pants choices, we'd have 6 shirt choices. And then for each of these shirt choices, we'd have 3 shoe choices. So we'd have 4 branches for the pants, and in each one of those 4 branches, you'd have 6 branches for the shoes. And at each of these branches for the shoes, we'd have, or shirts, excuse me, we have 6 branches for the shirts. And at each of these branches for the shirts, we'd have 3 branches for shoes. So if we counted then the total number of branches at the end, we'd have the total number of possibilities. Well, it's a little bit easier than that. What this boils down to by the fundamental counting principle is we have 4 ways that the number of pants or 4 choices for the number of pants, and 6 choices for the number of shirts, and 3 choices for the number of shoes. So if I multiply those together, I'm going to get the total number of outfits, which is 72. So the fundamental counting principle is pretty easy to deal with. Another common situation that we'll ask you about is the number of different license plates. So in Michigan, where we live, one license plate format that we have is 3 letters followed by 3 numbers. 3 letters followed by 3 numbers. How many different license plates can we make in that format? And we say format because there you guys have seen, like, there's some now in Michigan, there's a bunch of different ways that these license plates are formatted. Some have like 4 letters and 3 numbers, or 3 letters and 4 numbers, and some of them have like the college license plates and stuff, but this is one of them. So if you think about that, we basically have 6 events going on, right? We have 3 letters, and then we have 3 numbers, right? So how many choices do we have when we choose a letter? Well, if you think about it for a moment, maybe you recall that there's 26 letters in the English alphabet. So for the first choice of our letter, we have 26 choices, A through Z. For the second letter, we again have 26 choices. We have A through Z. And for the third letter, we again have 26 choices. We have the letters A through Z. Now we'll go to the number spots. For the first number, we have 10 choices. We have the digits 0 through 9. For the second number, again, we have 10 choices, the digits 0 through 9. And for the last letter, again, we have 10 choices, the digits 0 through 9. So if I apply the fundamental counting principle, all I need to do is multiply 26 together 3 times and multiply that to 10 3 times. So I would say like 26 to the third times 10 to the third. And when I type that into my calculator, I get 17,576,000 different license plates. Okay. The next situation that we want to talk about is something called a permutation. And a permutation is a special type of counting where we're basically asking how many different ways can we order some objects. So for example, let's say we just have the letters A, B, and C. If we wanted to know the number of permutations, one way we could do this is just kind of exhaustively, and we could write out all the different ways we can order them. We can do A, B, C, do A, C, B, we can do B, A, C, we can do B, C, A, do C, A, B, we can do C, B, A. If I look at that, I think we got them all. That's 6 different ways. Well, it turns out that there's an easier way to think about this. Basically, we have 3 choices to make. We have what letter comes first. So when we do that, we have 3 choices. We could pick A, B, or C. And then we'll have the second letter But now we only have two choices, right? We've chosen either A, B, or C to be the first letter, so we can't choose that one to be the second letter. So there's only two choices left. And then for the third letter, we've picked the first letter, we've picked the second letter. That only leaves one letter left. That letter has to be the third letter. So we give this kind of thing a formula because when we do counting, we end up doing this sort of situation again. We represent this with the symbol 3 with an exclamation mark after it. This we read as 3 factorial. So that exclamation point at the end is the factorial symbol. So our definition, n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 all the way down till we multiply like 3 to 1. So for example, if I wanted to do 10 factorial, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it turns out there's a factorial button on our calculator that we can use so we don't have to type all of this stuff in. Let's show you how to find that. So if you take out your calculator, I'll wait a minute for you guys to take out your calculator so you can follow along if you'd like. Or if you need a minute to find it, just press pause and go look for your calculator so you can follow along. So if I want to do 10 factorial, I'm going to type it in just like it looks on my sheet of paper. So I'm going to do the number 10, so there's my 10. And then to get the factorial symbol, I'm going to press the math button. I'm going to go over to the PRB menu. PRB is short for probability. And then I'm going to go down and there's my exclamation point or my factorial symbol. So if I type in 10 factorial, that tells me it's 3,628,800. Okay. What if we are only interested in ordering some objects? So suppose there's this situation. We have 10 competitors in a race, and we give out 3 medals for first, second, and third. How many different ways could we give out those medals? So if I think about this, there's 3 choices we need to make. We have the first medal, we have the second medal, and we have the third medal. So when giving out the first medal, we have 10 competitors. So we'd have 10 possible people that we could give that first place medal to. But after we've given out the first place medal, you can't also finish second place and first place in the same race. So there's only now 9 choices for our second place medal. And for third place, well, you can't finish third if you've already finished second or already finished first. So there's only 8 possible people that could be given that third place medal to. So remember that 10 factorial was 10 times 9 times 7 times 8, or 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we only wanted one piece of it. We're going to give this sort of a calculation a name and a special symbol associated with it, because we're going to do this kind of calculation a lot of times. So we say that this is a permutation because we're talking about how many different ways we can order something of n objects taken r at a time. So in this previous example, we had 10 objects taken 3 at a time because there were 3 places. There's a first place, a second place, and a third place. 3 medals to give out. So the symbol that we're going to use to denote this is n, which is a subscript, a big P, and then an R that's a subscript. And this is going to be n factorial over n minus r factorial. So if we went back to our previous example, up here, we'd have 10p3, so that's 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you notice, everything canceled out but the 10 times 9 times 8. So you're like, why am I doing this hard of a calculation? Well, it's because the calculator also has this programmed in, and we could just type this into our calculator, but I wanted to kind of show you what that formula is really saying. So for example, if I just wanted to do 10p3 on our calculator, I'm going to go ahead and turn it on. I'll type in the number 10. I'm going to press the math button, go over to the PRB menu, and you'll notice the NPR command is right there. Command 2. So I already have the 10 there is in place of the N. And I'm going to put the number here in place of my R. So this is 10p3. And that's 720, which you'll notice that matches exactly what we got here when we did 10 times 9 times 8. I guess I never, multiplied that out for us. I got excited, but it is 720. Okay. And the last kind of counting that we're going to talk about in this first section is permutations with repetitions. So for example, let's say how many different ways can we order the letters that make up the word I? Well, okay, so we could have E, Y, E. We could have E, E, Y. Can we have Y, E, E? But that's it, because these capital E's are exactly the same letter. So there's only there's less number of ways we could arrange them than we could if all 3 letters were different, right? Remember when we did A, B, C, there was 6 ways. Here there's only 3. So what's going on here, or the way we can do this easily, is we can say that our number of permutations, and this is going to be a formula, so we'll want to make sure we remember this. Oops. So we have the number of permutations equals n factorial over s1 factorial times s2 factorial all the way out to some sk factorial, where n is the number of objects we're permuting, of those n objects, we have k distinct objects. So k must necessarily be less than or equal to n. It can't be bigger than n. You can't have more objects that are distinct than you have objects to permute. So S1 is the number of object 1. S2 is the number of object 2. And all the way down to Sk being the number of object 3. So if we take this back to our example with EYE, here we have n is 3 because we have 1, 2, 3 total objects. My k is 2. I have 2 distinct objects. We have e's and we have y's. So S1 could be for, we'll say 1 is representing E and 2 is representing Y. S1 is 2 because E occurs twice, and S2 is 1 because Y occurs once. So I can say then I have 3 factorial over 2 factorial times 1 factorial, which then I could type into my calculator, and I'll get the 3 that I showed you earlier, but let's type it in just to prove to you guys. So I'll do the fraction command, alpha y equals, I'll do 3 factorial. Again, to get the factorial, I press the math button, over to the PRB menu, and then command 4, and then 2 factorial, and then 1 factorial. Do I really need to type in the 1 factorial? You don't, because 1 factorial is just 1. But that gives me 3. Let's do another example that's a little less trivial. Again, this one wasn't hard to do by hand, but I chose something that we could do by hand just so it would be a little bit easier for you guys to see how it works. Let's say we want to do how many different ways we can arrange, I should say distinct ways we can arrange the letters in Tallahassee. So the first thing I'm going to do is I'm going to count up the number of letters that I have. So I have 11 letters. Then I'm going to count up the number of times each letter occurs. So I have 1 T, I have 1, 2, 3 A's, I have 2 L's, I have just 1 S, H, I have 2 S's, and I have 2 E's. So my number of distinct permutations is going to be 11 factorial over 1 factorial, but I don't really need to write that because 1 factorial is just 1. 3 factorial times 2 factorial times 1 factorial, which I'm not going to bother to write, times 2 factorial times 2 factorial. And then I'm going to just go to my calculator and type this in. So again, alpha y equals, so I'm going to do 11 math probability command 4 over 3 and math probability command 4 times 2, and let's actually do it this way. We'll do 2 in parentheses probability command 4 and then to the 3rd power, just so I don't have to go through quite so many menus. So I just have 2 factorial happening 3 times. So I get 831,600. Okay, so that should be enough for you guys to be able to do the assignment for this section 1. Good luck.